Error Handling and Assertions in Solidity, Module 2, Video 7. Error Handling and Assertions in Solidity aims to provide you guys with a comprehensive understanding of how to handle errors and use assertions in Solidity. This video will help you guys grasp the importance of error handling for creating robust and secure smart contracts. Key topics. There are four major key topics that we will be covering today. The first would be the introduction to error handling in Solidity. You might ask, what is error handling in Solidity, right? So you must have encountered errors previously, right, in different programming languages that you might have already explored, like even the very basics of other famous languages like Python, C, C++, Java. You might have always run into errors in your program, right? Syntax errors, semantic errors, lots of types of errors are there. So similarly, Solidity is just another programming language, right? And it too can have errors. So you should know how to handle these errors to ensure the creation of robust and secure smart contracts, right? Error handling ensures that the contract behaves as expected and that errors are handled gracefully. Okay, so there are three major functions that we will use for error handling. Okay, the first would be the require function, then the assert function, and then the revert function. I'll go into great detail about these individually, but to give a small overview about each one of them, first would be using require function for error handling. The require function is used to validate conditions and ensure that they are met before executing the rest of the function. If the condition fails, the transaction is reverted and an optional error message can also be provided. The second would be using assert for assertions. The assert function is used to check for conditions that should never occur. If the condition fails, the transaction is reverted, and it typically indicates a bug is in the contract. Third and the final one would be using the revert function for error handling. The revert function is used to revert the transaction and provide a reason for failure. It is typically used for more complex error handling. So this is a sample Solidity code in front of you, right? You might have already got to know the basics of writing Solidity code, but I'll just go through this code just to give you a quick recap and revision. So Pragma Solidity 0.80, as you know, version of 0.8.0 or higher is used. And in this contract bank, this line declares a new Solidity contract named bank. Then you're mapping the address to uint in private balances. So this essentially declares a private state variable balances, which is mapping from address to unsigned int, right? It stores the balance of each address that interacts with the contract. The private keyword means that this variable can only be accessed from within the contract itself. You must have already studied all of this. I'm just giving a quick recap. And the second is the deposit function. You must have already explored simple basics, right? Now, what is interesting is the withdraw function. I have put a require condition here. So this is what we are going to be doing today, what a require condition does. And in like all of the three functions that we are exploring, require is one of them, and we'll explore what the require function does, right? So what I have written is require amount greater than less than balances messages.center and the message is insufficient balance. Oh, I have put a condition here that the amount has to be greater than the balance, right? If it is not, it will show the message insufficient balance. If this requirement is successfully fulfilled, right, then the amount would get subtracted and we are using the payable message.sender transfer amount, right? And again, finally, function get balance public view returns you and return balances, right? You must have already learned the syntax in previous classes. I'm not going to waste so much time on that. But what I tried to show you was how the require function worked in a very brief manner, right? Okay, so introduction to error handling. We'll take this in two ways, an explanation and an analogy. Let's go through the explanation first. Error handling is essential for creating robust and secure smart contracts. As I told you, it ensures that the contract behaves as expected and that the errors are handled gracefully. Analogy. Error handling is like safety checks in a car that prevent it from starting if certain conditions are not met, ensuring that the car operates safe. Like everyone might have seen a car, right? It always has certain safety checks without which the car would not run, right? You always have to ensure that these safety checks are taking place. You can take a car, an airplane, a train. You always have a checklist of safety checks that you have to ensure are working before you can operate the vehicle, right? So similarly, that's how error handling works, right? It's like safety checks, which if are not met, indicates that the contract will not be deployed successfully. So first would be using the require function for error handling, right? Again, let's go through an explanation and an analogy. The require function is used to validate conditions and ensure that they are met before executing the rest of the function. If the condition fails, the transaction is reverted, and an optional error message can also be provided. Okay, let's go through a simple analogy. Using require is like a pre-flight checklist for a pilot, ensuring all conditions are met before takeoff. Anyone might have seen any pilot video or any game you might have played about flight simulators and all of that, right? There's always a certain checklist before you can actually start flying the plane. You just can't get behind the wheel and fly the plane, right? You have to make sure that certain things are working in perfect order, certain things are present in the plane, right? That the engines are in working order, the amount of fuel is more than the necessary level. There's a certain pre-flight checklist always for a pilot, and he has to check all of those options. Similarly, that's what require function does, right? It checks if the requirements are complete, and then only the contract is deployed successfully. Otherwise, if the condition fails, the transaction is reverted, and an optional error message can also be provided if you wish. The second function we would be exploring is using assert for assertions. Again, explanation, analogy, and this time we'll also take a code example, right? So, explanation. The assert function is used to check for conditions that should never occur. If the condition fails, the transaction is reverted, and it typically indicates a bug in the contract. Now, the difference between require and assertions, right? So, require checks for conditions that need to be there, whereas assert checks for conditions that should not be there. In the plain example, using assert, you check the requirement that enough fuel is there, right? You need enough fuel for the plane to operate successfully. Whereas, if you're using the assert, you're checking a condition that should not be there. For example, brakes are not working successfully. This should not occur, right? For example, brakes are not working successfully. This should not occur, right? If the brakes are not working, the plane cannot operate successfully, right? If this condition does not work successfully, you abort the mission, right? You abort flying. Similarly, that's how assert works, right? An analogy that we have used here is using assert is like an emergency brake in a car, stopping the car immediately if something else goes wrong. So the explanation, as I explained, it is used to check for a condition that should never occur. If this condition fails, the transaction is reverted and it typically indicates a bug in the contract. If there is a failure, this emergency brake is put and the transaction is reverted. And this shows that there is a bug in the contract, right? A simple code example that is given here. We have taken a contract called safe_math. We have added a function called safe_add, where we have taken uint A, uint B. It's public. Yeah, and we can see that pure returns uint, where uint C is equal to A plus B, and we have asserted the fact that C is greater than equal to A. This is there to ensure there is no overflow return C, right? So this is how assert basically works. It's an emergency brake in the analogy given, right? It's an emergency brake that stops the car immediately if something goes wrong, right? That's how in trains you have emergency brakes, in cars you have emergency brakes, right? They'll notice a fault in the system and they'll stop completely. The transaction will be reverted, right? So again, it is used to check for conditions that should never occur. Again, this is a sample Solidity code. I have presented this in a more efficient manner. Contract safe_math, function safe_add, uint A, uint B. Okay, public pure returns uint, right? Now we have given that uint C is equal to A plus B. We have asserted the fact that C is greater than equal to A. This is there to ensure that there is no overflow. We ensure that C is greater than equal to A to ensure that no overflow takes place. Cool. Okay, let's move to the next one. Using revert for error handling, right? This is the final function. Again, explanation, analogy, code example. Explanation. The revert function is used to revert the transaction and provide a reason for the failure. It is typically used in more complex error handling. So the analogy that we will use is using revert is like a warning system that stops a machine and provides an error message when something goes wrong. right? So there's a warning system, like you're in factories or somewhere, right? And there's always a warning system. For example, in a machine, if the electricity consumption is much too high, like it can be hazardous, right? So there'll be a warning system and the machine will be stopped and an error message will be provided, right? These are safety measures that are there in place. So that's how essentially how a revert function works, right? The revert function is used to revert the transaction and provide a reason for the failure. So we are creating a contract called a vending machine and we have taken the price as 1 ether, right? We are creating a function by, again, public variable. So here we have put the condition, right? If message.value is less than price, we will revert with the statement insufficient funds to buy the item. This is the logic to dispense item, right? If the buyer has enough funds to buy the item, then only he will be able to buy the item, right? This is the basic logic of economics, right? You should have the amount that is required to buy the item for, right? If something is 100 rupees, you should have 100 rupees. So it's checking that if you have less than 100 rupees, say 40 rupees, you cannot buy the item, right? Because vending machine is something that's automatic. Similarly, that's how smart contracts work, right? It's called smart contract for a reason. So now we'll come to the best practices for error handling, right? So in explanation, we will discuss the best practices for using require, assert, and revert to handle errors effectively in Solidity. The analogy would be best practices for error handling are like following safety protocols in a factory to ensure smooth and safe operation, right? So best practices use require for input validation and conditions that should be met before executing the function. Use assert to check for conditions that should never occur, typically to catch bugs. Use revert for complex error handling and providing detailed error messages. Always provide meaningful error messages to help with debugging. Use assert for input validation as it consumes more gas. So these are best practices that have been suggested, right? So you always have a set of recommended practices to follow, right? You must have gone to a chemistry lab. There are a set of practices you should follow, right? Always wear goggles, handle hazardous chemicals carefully. These are also practices that have been recommended for error handling, right? So again, safety protocols in a factory to ensure smooth and safe operation, right? That at this stage you have to follow this protocol. At the next stage you have another protocol. Right? Simple. So it shows you how to use the three different type of functions, require, assert, and revert effectively. You use require for input validation, right? And one of the reasons for this is if you use assert for input validation, it consumes much more gas. And we have to make our smart contract as gas efficient as possible, right? Okay. And then we use assert to check for conditions that should never occur, typically to catch bugs, and use revert for complex error handling and providing detailed error messages. Best practice is to always provide meaningful error messages to help with debugging. Example of error handling and assertions. So we'll go through an explanation and an analogy. We will walk through a simple example of Solidity contract that uses require, assert, and revert to demonstrate their practical application. Right? And the analogy that we'll be using is we are building a smart contract system with pre-flight checks, require, emergency brake, assert, and warning systems, revert. This is the analogy we used while covering these, right? That it was pre-flight checks for require, emergency brakes for assert, and warning systems for revert. The sample Solidity code is again Pragma Solidity. These are all stuff you know, right? And this is an example of revert, right? This is the one we went through. We have gone through an example for each of them, and I'm just showing you the revert one again. How, like, we have set the price as 1 ether, right? If the buyer has insufficient funds, right? Message.value is less than price. That means we will revert this and show that they have insufficient funds to buy the item, right? Yeah, so this is the code for this essentially. And now we'll summarize all of them, right? So we'll go through a key point and a description. So the key point require. Require is generally used for input validation and ensuring conditions are met before executing the function. Right? And assert is used to catch conditions that should never occur, typically indicating a bug. And again, as I explained during the best practices part, you should never use assert for input validation. This is because of the high gas fees it uses, right? Okay. The third key point would be revert. Revert is used for complex error handling and providing detailed error messages, like, right? So you're explaining the error message to the person, why this error has happened, right? That, for example, I gave the example of using too much electricity in a factory machine, right? It is potentially threatening. So you're providing a detailed error message, right? That's what revert does. And again, when we come to best practices, I discussed all of them, when to use which one, right? And just remember that always try to provide meaningful error messages, right? You have to make everything as clear to the person using your contract as possible. And you would like to avoid using assert for input validation for the reason I gave, the high gas fees. So an interactive exercise or quiz for you would to define a function that uses the require function to check for valid inputs. Okay, next you can implement a function that uses assert to catch unexpected conditions. Next, you can create a scenario where revert is used to handle complex error conditions. Finally, a good practice for you would to explain the difference between require, assert, and revert, and when to use each. This is just to get a more clear understanding, right? When you should use require, when to use assert, and use revert, so as to not get confused between all of them. Yeah, that's it. Thank you very much.